Hello. Today's lecture is about Newton's second law. Newton's second law can be described by a simple formula. That is, net force equals mass multiply acceleration. Net force equals mass multiply acceleration. So the force is a vector. Acceleration is also a vector. Because force has a direction. A force has a direction. And acceleration also has a direction. So the formula is very simple. So we need to do some examples to show how do we use the formula. Example 1. I have a box and the box is let's see, 4.2. Mass is 4.2 times 10 to the 3 kg. Okay. I have two forces acting on the box. One is this way. 1.8 times and another one is and this dotted line is horizontal and the angles here 37 degrees. Another angle here is 12 degrees. Okay. Let me erase this because make it clearer. M is 4.2 times 10 to the 3 kg. Okay. Okay. Net force equals mass times acceleration. What do we want to find? In this question, we want to find what A is, what the acceleration is. So we want to find the acceleration. So what we need is the net force. We have discussed how to find the net force in one of the previous lectures. We use triangle method move this vector to this position such that the head of the first vector touches the tail of the second vector. It's head to tail. So let's do that. So this is that big. Because we need to use a calculator a little later on, and instead of entering 10 to the power 3, instead of entering this into the calculator, I just make it simpler, just 1800. So this force is 1800 Newton. And this force is 1300 Newton. And the sum, let's make it bigger, okay. And the sum is this. So this is my F net. Okay. We use cosine law. To use cosine law, I need this angle. This angle is, if I extend this, then it is very obvious this angle is this angle. So this angle is 37 degrees plus 12 degrees. Let me erase the 1300. 1300. Let me erase this. So this is 37 plus 12 degrees. Okay? It's very clear there. Then this angle is 180 degrees minus this. This is 49. So this is 180 minus 49. This is equal to 131 degrees. So this is here. 131 degrees is this angle. Now we can use cosine law. Fn square is equal to 1800 square plus 1300 square minus 2 1800 1300 and a cosine 131 degree. It's here. Yeah, okay, so this is Fn. So you use a calculator to find this, and once you have this value, you square root it. So Fn is, take square root. Okay? So use the calculator to do that. And you have the answer. Let's see. So Fn is equal to 2828 decimal use your calculator, and the calculator shows you all the decimals, all the digits available. So this you need to you can round it. So it's 2.8 times 10 to the 3. Move the decimal from here to here, and you write this, and this is your net force. To find the acceleration, divide the net force by the mass. So the acceleration is net force divided by mass. Mass is this. And you get an answer. The answer is when you use the calculator to do this calculation, again you get many digits, and you round it, you get this answer. Okay, that's the answer, A. However, since the acceleration is a vector, so this is a magnitude, but what is the direction? So you draw a horizontal line. You want this angle. You want this angle. So this is a horizontal line. I already know this angle, this is the horizontal line, this angle is 37. So I know this is 37. I have the triangle. I can use sine law to find this angle. Once I have this angle, I subtract this angle from 37, I get this angle, you see? And this is the angle I want, because usually you label the angle with respect to the horizontal or with respect to vertical, whatever. So I need to find this angle using sine law. So the sine law is The sine law is sine 131 degree divided by Fn is equal to sine, let's call this theta. Sine theta over 1300. So I put Fn, I put the answer Fn into here. I can find sine theta. Once I have sine theta, I can find theta, right? It's just inverse of sine, arc sine. So use your calculator to do this sine law, and the theta is you have theta is 20 something. 20 20.29. So this angle, the angle where I have, let's say this alpha, or let's call this alpha. So angle alpha is 37 degree minus 20.29, and this is equal to 17 degrees. It's equal to 17 degrees. So you have the magnitude of the acceleration and you have the direction of the acceleration. So this question is, the first step is to find the sum using triangle method. Use cosine law to find the net force. Once you have the net force, use the Newton's second law, find the acceleration. So you need to find the magnitude of the acceleration and the direction of the acceleration. To find the direction, you use sine law. So that's this question. Let's have a second example. So the second example I have an inclined plane. $18 degrees here and 25 here. $25 meters. And the mass is at the top. This is the mass. This is the mass. The mass is m. Okay. First, at the beginning, you hold the mass. You hold it. And then you let go. So the mass will slide down the inclined plane And the question is to find what is the velocity at this point. When the mass reaches here, what is the velocity? The velocity is what? Because the question is this, at the beginning I hold it and then let go. Therefore, the initial velocity is 0. So the velocity here is 0. Let's call the initial velocity v1. Then at this point we can call it v2. So I want to find what v2 is. So for this part, I need kinematics, the equations of motion. I need equations of motion. But to find the equations of motion, I need to know the acceleration. And to find the acceleration, I need Newton's law. Force equals mass times acceleration. So I need a force. What is the force in this question? So the mass is, let me make the diagram bigger. The mass is this, m. This box or this block has a force of gravity. The force of gravity is mg. Force of gravity is mg. Next, I want to resolve this force of gravity into two components. One is parallel to the inclined plane. Another one is perpendicular to the inclined plane. So I want two components. To find the components, I draw a rectangle. Draw a rectangle. What components do I need? Look here. This box will slide in this direction. This component is in this direction. Therefore, this component is the force which causes the block to slide down. But this component is not the force to cause the motion. So what I want is just this force. Is just this force. So I want to find how big this force is. This is mg. What angle is this? This angle is the same as 18 degrees. Why? Oh, okay. So this is along the inclined plane. And the inclined plane, this is horizontal. And this is 18 degrees. You see, this angle has two sides. This side is perpendicular to this side. and this side is perpendicular to this side. So you have two angles. The two sides of this angle is perpendicular to the two sides of this angle. Therefore, the two angles are equal. We have talked about this before. So remember this. It's very useful. If you have two angles, and the two sides of one angle is perpendicular to the two sides of another angle, then these two angles are equal. Okay? So this is 18. Now because this is mg, so what is this? This is the opposite side of this angle. And this is the hypotenuse of this angle. Therefore, this is sine relation. This angle, this force, F, let's just use the letter F. This force divided by mg is equal to sine theta, sine 18. Okay? So this force is V1 is 0. So this force is mg sine 18. Okay? This force is mg sine 18. Multiply mg to the right hand side, so force is mg multiplied sine 18. Okay, so let me erase this, okay, and carry on to find the V2. Oops, V2. So now this question, V1 is 0, V2 is unknown, and the force is this. Then what is the acceleration? This is the force. Force is m times acceleration. So the m cancels. The acceleration is g18. G sine 18. Okay. So I know the acceleration along the inclined plane, and I know V1, and I know V2. I know this 25. So I can find how long is this distance. Now this is a hypotenuse of relative to 18 degrees. And this is the opposite side relative to 80 degrees. So again, this is sine relation. Sine 18 here. Sine 18 is 25 over this distance. Over this distance. So this distance is 25 over sine 18. Okay, once I know the distance, I know V1, I know V2, I know A, then it is kinematics question. What formula do I use? I use this formula. V2 squared equals V1 squared plus 2AD. V1 is 0, therefore it's 2AD. Then I have 2 times A is this. Whoops. A is this. I don't need A is G sine 18. And D is 25 over sine 18. You see, sine 18 and sine 18 cancels. Therefore, my V2 is 2G times 25. Now it's so simple. Just use a calculator. G is 9.1. So you multiply 2, 9.1, and 25. After that, you take square root and you get V2. So the answer V2 is 22 something. Yeah. So V2 is, after you round it, it is 22 meters per second. 22 meters per second. Okay, this is the answer. You got it? Okay. So let's do another example. Let's see, another third example. All right. The third example is I have 2 blocks. This is 32.5 kg, and the other one is 40. Okay. Okay, there is no friction, okay. Oh, by the way, in today's lesson, friction is not considered. The friction is 0. There is no friction in today's examples. No friction. Look at this. Because there is no friction here, this will drop, and this will slide to the right hand side, right? This drops, this slides to the right hand side. So there is acceleration here, and there is also acceleration here. What causes the acceleration? The force of gravity is down for this block, but the motion is this way. Therefore, the force of gravity does not cause this acceleration, right? But the tension here, on the rope here, the tension is pulling, therefore the tension is the cause of the motion. The tension will make this move to the right hand side. For this block, the force of gravity is down, therefore this force will make this block to move down. So this force is the cause of the motion. But how about the tension? The tension here is pulling up. The tension tends to move this up. However, you look at this. The tension here, they are internal forces. When I say internal, I am talking about the combination of this box and this box. These two boxes together. Consider them together. Therefore, the tension here is internal forces. It's not external forces. When we consider this block and this block together, then what force causes them move? This goes down, this goes up. What force causes this way? You understand? What force causes the whole, let's use the word system. What force causes the whole system to move this way? The force which causes the motion is just the force of gravity of this block. This force of gravity is the external force on the system. Tension is the internal force. Of course, there is external force of this gravity, but this external force does not cause this to move this way. So the only force which causes the motion of the system is the force of gravity. Therefore, the net force is the force of gravity of this block. So the net force is mg 40 times g. This is the net force. The net force causes the system to move. Mass times acceleration. What is the mass of the system? (32.5) plus 40. That's the mass of the system times acceleration. Oh, I forgot to mention, what do we want to find? We want to find acceleration is what? And also I want to find the tension is what? Okay? The tension is here. Because this is one string, or you say one rope, therefore the tension here and tension here are the same. The tension on a one rope is the same. Everywhere is the same. They're the same. Okay. So I want to find these two quantities. Now I have the A here. So just do this. A you can find. Use your calculator. This is 9.8. Use your calculator to find A. And A is this is the answer. Use your calculator, all right? So I know the A now. How do I find the T? Remember, T is not an external force. T is the internal force. Because it's the internal force, I can consider each block individually. You can consider this block to find the tension, or you can consider this block to find the tension. Which one is simpler? This one is simpler. Because the motion is horizontal, the tension is horizontal, but the force of gravity is vertical, so the force of gravity has nothing to do with this motion. So this tension, T, horizontal, is equal to MA. M is 32.5. Times A. And you put the A here now. Then you can find the T. And the tension is, if you run it, it's this. Or it's equal to 1.8. All right. So this is the answer. Okay. Use this as 40 times G as the external force, and this is the mass of the system. You find the acceleration. Once you have the acceleration, you multiply the mass of one block. You get a tension here, because this tension is applied to one block only. This is the internal force. So you have this, and you can write in scientific notation. I hope you follow this work, all right? Okay, so let's show another question. Another question is a variation of this. You also have two blocks, but one of the blocks is not moving horizontally. So just a small variation. So you have a ceiling, and the ceiling, this is a pulley. Okay. You still have this block hanging vertically, but the other side, the block is not moving horizontally. The block is on an inclined plane. This is 4.2 kg. And this is 1.8 kg. Now you look at this. This is much heavier than this one. So you will imagine that this will drop. This will move down. This will move up. Because they are tied together, so this acceleration and this acceleration are the same. This is A, this is again A, they are the same. Now, the difference between this one and the last one is that what is the force which causes the motion? The motion is this down and this goes up. What force is the cause of the motion? So of course you say immediately because there is the force of gravity which pulls it down. But how about the force of gravity here? This force of gravity will pull this down. However, this mass is quite small compared with this mass. So the force of gravity here, the force which pulls it down the inclined plane is a component of the force of gravity, right? So this force of gravity is to pull this down. The component of this force of gravity is to pull this down as well. Because they move in this opposite direction, yeah? Down here and down there. So this force must subtract the component of this force, and that is the net force which causes the system to move. So the net force is 4.2 G minus 1.8 G. This is the force of gravity. But I want the component. So remember, the component is the sine of this angle. What is this angle? 32. So the component of the gravity is this way, and this is the sine of the force of gravity. So this is the net force. This net force applies to the system. So if you divide by the total mass, or you call system mass, so you divide 1.8 plus 4.2. Then the answer is acceleration. And if you do that, the acceleration is, you get the acceleration, right? Yeah, you get the acceleration. Acceleration is use a calculator to find the acceleration. Acceleration is just this part. And again, you want to find the tension. Okay, so let me write. So this question is, what is the acceleration and what is the tension? So tension. To find the tension, because it's the internal force, you need work on this block or work on this block. Which one is simpler? Of course this is simpler because there is only one force of gravity. But here you need components. So apply force equals ma for this 4.2 kilogram. So this is pulling up, force of gravity is pulling down, and the acceleration is down. Therefore, you have 4.2 g, that's the force down minus the force up, is equal to mass times A. A is 5.3. So, then you find the T. So finally, T is 4.3. Okay. So this is the answer. I'm not sure whether you follow this or not. I am doing this quite quickly, right? Quite quickly. If you watch this YouTube video, you can save it in your computer. You save it, and you watch it. You replay it. You play back slowly. No, you cannot control the playback speed, but you can watch the video. When you come to a point you don't understand, you just press pause. You press pause and you think about it. Okay, this is about Newton's second law. I'm not going to talk about Newton's third law. It's action and reaction concept. So this lesson, together with the last few lessons, is about Newton's law of motion. The next lesson will talk about, again, the law of motion, but we will incorporate force of friction. Good. Goodbye. Thank you for watching.